Hello everyone, this is Alex and welcome back to my video series on solving LeetCode problems. On this video we're solving problem 1466, reorder routes to make all paths lead to city 0. So just a disclaimer, I did it, I tried it, and it almost worked because as you can see I succeeded in 75 out of 76 test cases and I had a time limit exceeded on the last one. So I think maybe if I just submit again, I might be lucky. But there's a better way to do what I just did, and I want to share that. So let's see if for some reason it gets faster and I succeed. No, time limit exceeded, same thing. So I'll explain to you the problem first. So the problem here is that we have cities in the country, and the cities are connected by edges, and they're directed edges. So this means that 0 is connected to 1, and that doesn't mean that 1 is connected to 0, which is fine. And there's one important detail here, which is something that we can actually use to... This is why my solution is more general, but it's slower. But there's one improvement, which is there are n-1 roads, and there's only one way to travel between two different cities. This network forms a tree, and so what does this mean? This means that there can't be a node that is empty, and there's n-1 roads, so there can't be something like this, like a cycle. Yes, there can't be a cycle. Or something like this. And this is what I didn't really pay attention to, and this is why my solution is slow. So there can't really be this, because we have 4 edges, 4 nodes, and we have 4 edges. We can have at most 3 edges, n-1. So this is valid. This is valid. Okay, so let's look at the problem. Let's continue looking at the problem. So in this case, we want all of the cities to connect to 0, because there's going to be a big event at city 0, which is like the capital, like a big concert. And they want to invert edges in order to make every city connected, and they want to find out the minimum number of edges they need to invert to get all cities connected. So in this case, the only city that connects to 0 is 4, and 4 connects to 5. So if we invert this, then 5 gets connected to 4, and consequentially gets connected to 0. So we invert 1, and we get this city. 2 is connected to 3, but 3 could be connected to 1 if we invert it, and 1 could be connected to 0 if we invert it. So we invert this one, and we also invert this one, and then 2, 3, and 1 are connected to 0. So the number of edges that we need to invert is 3. Another scenario here, we just invert 2 of them, and then 4 gets to 3, 3 gets to 2, 2 gets to 1, 1 gets to 0. Great. So how did I solve it and it was too slow? So let me just give you a quick example. So let's say something like this. So yes, this is city 0, 1, 2, 3, and 4. And which cities are connected to? First of all, I want to know which cities are connected to city 0, directly or indirectly. So I pretty much invert the edges, so reverse them, and I do a breadth or depth first search or breadth first search from 0 all the way to where I can get. So I get to 0, 1, and 2. These are the cities that are connected to 0. 0 is connected to itself. So then I need to iterate through the remaining cities and check if there is an edge that connects one of these to that new city. So we'll start with city 3. Is there an edge that connects 0 to 3? No. 1 to 3? No. 2 to 3? Actually, there is. So we can just invert it. And we invert it, and that's our first inversion. Invert equals 1. We inverted one of them. And now 3 is connected. Voila. And then we continue for the missing ones. We check 4. Well, since we just changed 3, we still need to check if there's an edge connecting 4 to one of these now. And if that is the case, then, well, then we don't need to invert anything, and let's just add 4 here. And there are no more cities, no more nodes, so yeah, solution was 1. Cool. However, and let me just, okay. So this solution also worked if there was something like this. This also worked because I would check with a breadth first search the numbers that are connected to 0, and this edge, it wouldn't really matter. However, in this problem, we know for a fact that this edge cannot really exist. Well, it can exist, but this edge would not have, one of these edges would not have to exist, one of these 3 edges. Because we have 1, 2, 3, 4, 5 nodes, and now 1, 2, 3, 4, 5 edges. And we can only have n minus 1 edges. So this cannot exist. And this gives us an advantage because we know that a node is only connected, can only be reached by another node by a connection that exists, or by inverting an edge and turning that connection to exist. So either we invert, if there is how can we do? There is no other way of getting from one node to the other. There is no other way. So if there is an edge that needs to be inverted, then that means that there is no other way of getting there. Just to create that example again, in this case we could get from node 2 to 0 if we inverted this, but that would mean that there wouldn't be another connection. So let's say if we remove all of the, if this is not directed, it becomes undirected, that cannot be cycles. Also another way to look at it. Okay, given this, we know that, let me just remove this, and this is my new approach now. And I looked at the solutions because I didn't know, and I was tired and I felt defeated. So the thing is, let's save the cost of getting from one node to the other, given the edges. So we have let's say we have a dictionary that saves, okay, 0, 1, 2, 3, and 4. I'm just going to move this, or I'm going to make it smaller. So 1, 2, 3, and 4. So from 0 to 1, I can, what if I wanted to go from 0 to 1? Well, I would have to pay a cost of 1, which would mean I would have to invert it. So 0 to 1, the cost is 1. And that's my edge. If I wanted to go from 1 to 0, the cost would be 0 because they're connected. And if I wanted to go from 1 to 2, because this exists here, I would have to say 1 to 2, the cost is 1. I would have to invert 2 to 1, 2 to 1 is 0 because I don't need to invert anything. And 2 to 3, I would need to invert. Same thing, 3 to 2 is 0. 3 to 4, I will need to invert. And then 4 to 3, I would not need to invert. So this is my costs, connections and costs. So now I start with 0 here. Yeah, that's pretty cool. So I want to get I start with 0, and then I want to check the sum of the costs that exist for the nodes that connect to 0 to connect to 0. So in this case, the sum is 1. But what about the cost of the nodes that connect to 1? In this case, it would be 0. But also 0. Wait. Wait a minute. Yeah, the cost would be 0, 0, 0, and 0. But if I had this one here to invert, let's say I had this to invert, the cost would be, the cost to get from all of them to get to 0 would be 1, because I would have to invert this one here. And let's say I had another one here that this would be 5. So the cost of the nodes that are neighbors of 0, the cost of 0 of this city would be the cost of all the ones to get to 1, which is the sum of all the ones that get to 2. All of this, 1 plus the sum of this one, which is 1. So if I have to invert this one and this one, the sum will be 1 from here and 1 from here, which is 2. And that's it. So if you, let me give another example just to make it clear. Let's say 5, there's 6, which is connected to 5. I'm just going to remove this right now. And also 3, 4, 7 here. And 3 is connected to 7 like this. So we start with 0, which is the cost of 1 plus 5. And 1 plus the cost of 1 plus cost of 5. And the cost of 1 plus cost of 5, well, just go, is 0 plus cost of 1, actually, plus sorry, 1 plus cost of 5. Because it's 0, because you can connect 1 to 0, but you need to invert this one to connect 5 to 0. And then the cost of 5 would be, let's replace cost of 5 is 0 plus cost of 6, which is connected to nothing, so it's 0. So we can just delete all of this. So we could just say that cost of 5 is 1. Then cost of 1, we would need to do the same thing. Okay, I hope this was a good explanation so far. So let's get to coding. So first of all, we do something like, let's call it costs. And that will be a dictionary of int and then list. And it will be something like this. And let me give an example here. It will be something like the cost of 0 to get to 1. 0 to get to 1 will be 0, but to get to 2, it will be 1. Something like this. And this is all the list. So how do I do that? Well, for connection from node to node in connections, I need to first initialize if from node not in, so I would need to create empty arrays for it. Actually, a simple way to do that would be to use a default dict of a list. So that's pretty much a dictionary that gets created with nothing, but when we try to access it and the key doesn't exist, it defaults to an empty list. So we don't need to do that. We just say costs of from node dot append to node equals, let's not do it like this, let's do the costs of this, the key is the node that we're at, and the costs of the others are the costs from that node to get to the one we're at. So to node is 1, and the opposite. To node is from node 0. So what do we end up having here? Friends, let's run this. I think I should put my camera to the left. So at this moment we have, let's look at the input. 1 is connected to 0. So if 1 is connected to 0, then the cost of 0, let's look, 0. So we have 1 going to 0 costs 0, but 0 going to 1 costs 1, and 2 going to 1 costs 1. So that means that 1 going to 2 costs 0, and we have an edge 1, 2. Okay, good. So now we need to do something recursively. So we can say that the costs is equal to the sum of x for x in costs. Let's do it final costs. Sum of x to x in costs of x and x, actually cost of x will be the 2 node, actually other node, and cost. So it's the sum of the cost of that in costs of for x okay, so we would start with I don't know, x equals 0 in costs of x. However, we also need to add the same thing, the sum of all the other costs that connect to this one, that connect this one. So this is a recursive thing. So I think what we can do is we can return a recursive, self-out recursive of costs. and we starting with node 0. So now we need to create another function, self costs. And costs is dictionary of int list, and current node, which is an integer. That returns an integer, sum. So return sum of, what was that? So x for x in costs of current node. So it was other node and cost, and I want to do cost plus self dot recursive of costs and other node. And I think this will work. See what happens. So we come here. We can actually, let's remove this. So let's just do something like, for other node cost in this, return value equals 0. This is just better for debugging. Return value plus equals cost plus self dot recursive costs and other node, and return value. So let's just put some breakpoints here. So yeah, now we start, and so we start with current node 0, and we have other node as 1, and the cost of that is 0, and the other node is 1. Cool. So the cost, current node is 1, and now ones. Oh wait. So now 1 will connect to 0. Okay, so I think I need to do something different, which is current node is 1, the other node is 0. Then I need to say, hey, that has been, this is like exactly where you came from, so how can I do that? 0 and minus 1, and can cause current node and maybe parent node. If other node equals parent node, continue, it's like ignore, and other node, and then current node. So the current node becomes the parent node. So yeah. Okay, so now we start here. The other node is 1, the current node is 0. You can see it here. So we go again. Current node is 1, parent node is 0. The other node is 0, so we ignore. And then the other node is 2. Okay, so we do that. Something like that. Continue. Parents don't matter. So return value of the other node now is 3. Cool. And now 3 and 2. 3 and 4. The cost. Which costs 1, 3 and 4. So let me just run this to the end. Didn't break anywhere. Why did it break? Oh, right. Because I already was here, so I just need to check the print. So it's 2. Solution is 2. Why? Let me look at this example. So 1 is connected to 0. Let me just move this to Paint. We have 5 of them because we have 0 to 4. So 0, 1, 2, 3, 4. So 1 is connected to 0, 1 is connected to 2, 3 is connected to 2, 3 is connected to 4. So yeah, if we change this one here, and we change this one, then we have 4 to 3, 3 to 2, 2 to 1, 0. Okay, so I guess this worked. Let me submit that. Let's see if I don't get a timeout now. Yes. Okay, so that's it. I hope you guys enjoyed it. See you later.